Oh It's tutorial time! Hello, hello, you guys should see me now. Hear me now, everything should be working. We can get started soon. We will be doing tic-tac-toe today, which will be our sort of our intro to arrays and object-oriented programming. And to get that started, we'll have to first formalize tic-tac-toe a little bit and put it into code. So I'll be transitioning us over to a slideshow very quickly, where we'll go over a bit of the theory we're covering, and then after we cover the theory, we'll be able to get into the practice and see exactly how the code we're implementing is going to look. So I'll transition over to the slideshow now. Alrighty. So here we've got our slideshow here. And we're talking about tic-tac-toe. Tic-tac-toe is a game which we play on a board, which we can represent as a two-dimensional array. And on that board, we have X's and O's. When you get, for an n by n board, if you have n X's or O's in a row, you have a win. So today we'll be going into arrays, and we'll be using loops to see if we have that win condition. So if we have n things in a row on a 2D array, we have a win condition. And then we'll also go into object-oriented programming, how we'll define the game. So here I've got a translation of all of the game rules in English and how they will look as code. So in English we have the fact that it's played on an n by n board. That means that we'll use an n by n array to display the game. Now this whole thing, this whole idea of English to programming kind of stuff, where you take ideas in English and you translate them into how you'd put them in code, is very useful. You'll see this a lot in stuff like actual programming when you're making apps for hackathons, or if you're asked to do something in a job interview. This is the kind of thing you'll probably have to do, where you have to describe how a problem can be taken from the real world into programming. So we check for an n length row for an n by n grid. You can think of it as 3 by 3, but I'm doing n by n, so it's more similar to our quiz questions. Then we check that grid for lines. We check that for a continuous line of a certain number of symbols. The players will take turns, so you have to play after the previous person. You can't, like, two people can't play the same thing in a row. Then players play an X or an O at every single turn. They either play one or the other, and that's like the data type. Each cell can either have nothing, an X or an O, and you cannot replace a symbol. So if there's already an X or an O on some place in the grid, you can't replace it. Here are some of the fields, some of the terms we're going to go into during this session. This is something you guys might want to screenshot, because this is the kind of question, or these are the kind of things you have to know for our first quiz. This will be all this stuff will probably be grilled on it a little bit. Maybe the null and stuff will be coming up on the second quiz, but this, especially objects, fields, static, reference type, that kind of stuff is stuff you want to know. So that kind of stuff is stuff you'll want to note down. It's also stuff we'll be working with in this session. And if you have any questions about it, I recommend that you ask. All right. Just making sure my mic is still going here, because I'm seeing my levels are off on OBS, but it looks like it's fine. So continuing. These are some more informations about how we're applying those concepts of objects and object-oriented programming into our game. So our symbol, our X or an O, is going to be a capital B Boolean. That's so that it can be true, false, or null. Our game is going to be a game object, which we'll define, and so our game tests and our game app will be static, which we'll also define shortly. Now that's it for our little slides, and if you have any questions about the slides before we go into the actual session, now is the time. Otherwise, we can get started with the code. So just let me know if you guys have any wonders about anything on those slides. All right, I'm just going to set up our project here, and we do still get a lot of questions on Piazza about project setup, so I'll create a new one here. We'll not use anything from the Tuesday session. It'll just be a brand new project, and we'll call it, let's say, Tic-Tac-Toe. Would be a good name for it. When I create my project, I just do Java and nothing selected, very basic. Nothing selected there, and I'll call it Tic-Tac-Toe. Finish that up. You guys don't have to call it tic-tac-toe. You can call it whatever you want. It does not matter. And in our project, today I'll be starting off with just creating some of the array-based methods. We're not going to worry right now about how the board gets there and any of that. We're just going to write some of our methods to check the win conditions. That's going to be how we sort of start up our game. So I'll create a new Java class. It'll be tic-tac-toe. And I'll write a couple static methods. But before I do, I'm going to send you guys a certain file, and it's going to actually tell you a bit about the format of how the assignments work in Comp 250. It's in this course, the way that the projects work is that we give you a tester that we supply, like a .java file, and you write your code so that it passes the tester. And then when we grade you, we have a tester that's more intense that we take as well, and that more intense tester similarly also runs your code, makes sure it works. But right now, I'll send you guys tic-tac-test.java, and that's what we're going to be writing basically for. We're going to be writing our code so that it passes that test. To add that file into our project, we'll open in Explorer for our work. That'll open our project. We'll go into the source folder, and we'll take that file I just sent, tic-tac-test.java, we'll drag that into our source folder. And then we should have tic-tac-test show up. Eclipse is the exact same. You just show in Explorer, and it works. And here, it's going to want to call certain methods. It's going to want to call a method called horizontal winner, diagonal winner, and vertical winner. And that's what we have to write. So let's write those methods now. We'll write just the signatures of the methods, then we'll fill them in. We'll say public static, and I'll tell you more about public and static in a second. Boolean vertical winner. And it needs to take an array of Boolean as an input. So Boolean double array, and I'll call it board. So this method will check for a vertical winner on our board. Now I'm gonna copy paste that over, paste it twice, one for horizontal and one for horizontal winner, and I want to do one for diagonal winner. Now again, any questions, guys? Any questions at all? Feel free to ask. I want it to be all very clear about it, because this is a pretty important thing. This is how you're going to be doing your assignments, so it's pretty important that you understand it pretty well. We want to make sure our method names are the exact same as they are in the tester. So here we've got tic-tac-toe.verticalWinner. That's the exact same name for the method as is visible in our actual class. And we'll worry about those compile time errors right now. So now what does it mean for it to be static? Well, it means that we can call these methods out here in a different class by just doing tic-tac-toe.verticalWinner. We don't have to initialize any object with the new keyword. We can just say tic-tac-toe.verticalWinner, and it plays. We don't actually have to instantiate any objects. And once we get into actually making our game playable and taking the game rules and making a playable game out of it, we'll understand what it means to instantiate an object. So here we've got our static methods, and let's write them. Now I'm going to write in comments what I think this method should do, and I'm going to ask that you guys can help me implement those. And then Maria is asking, could you show how to drag tic-tac-test into source again, please? Okay, so you right-click on your source folder, you click Open in Explorer. In Eclipse, it's right-click, show in System Explorer, I believe. Very, very similar. IntelliJ and Eclipse, in that sense, have quite similar interfaces. So then you have your source folder here. You just open that in your Explorer. On Mac, that would be a Finder, but it would look almost the same. Then here you've got your Java files, right? You just take that Java file that I sent to the Zoom chat, and you drag it in. I already did that, so I'm not going to drag it again, but you just drag that from your from the folder it's in from Zoom into this source folder, and then it should be visible. And then you'd be able to see those tests, and we'll be able to run those tests to make sure our code works. So now I'm going to explain in comments what I want horizontal or vertical winner to do, and I'll write vertical winner, then I will myself write horizontal winner, maybe. And you guys can write vertical winner, and then you'll send your result for how you think vertical winner should work to the chat, and we can see if we can implement you guys' solutions. So for vertical winner, we want to check verticals, meaning we check that lines that are vertical on the board have 3 of the same not null symbol in a row. Not null symbol in a row. That's what we want. We want it to be 3 of a same not null symbol in a row. So I'll leave vertical winner to you guys to think about, and to think about writing, while I write horizontal winner. So for horizontal winner, what I want to do is I want to iterate through our board, right? I want to go through every row of our board, and I want to see if I can get a consistent line in that row. So to get through all the rows in my board, I can actually very literally type for Boolean array, because remember a 2D array is just an array of arrays, row, we'll call it a row, in board. Right? This syntax might look a little bit strange because you might remember your for loops have always an int I and stuff. This is a different kind of for loop that can be very useful because it doesn't have an index. It's very easy to use. So here we'll just have access to a row variable, which is a 1D array. And we can just work with that 1D array. The syntax for this is what data type is going to be inside of the thing you're iterating through. This is the thing you're iterating through. This is the thing that you will be iterating on. This is the data type. This is its name. The name exists within the scope of this for loop. And then it just runs this for every single row that exists in the board. Clement asks to explain a bit more. If you can tell me what you'd like me to explain a bit more, I will most certainly explain it a little bit more.
Just so you know, you just mentioned that for the for loop, this is a very efficient way to iterate. How is it going on for the Boolean row and the semicolon board?
Sorry, you said.
Could you please?
Sorry, your audio quality was a little bit. Your audio quality was a little bit like low quality. Could you repeat that? Your audio quality was a bit hard to hear. Could you repeat?
Could you hear me now?
Yeah, I can hear you a little bit better now. Thank you.
Oh, okay. Sorry. I'm a little bit confused about this for loop because generally speaking, we were used like for int and two semicolon, but here is Boolean row semicolon board. Could you please explain it a little bit more?
Yes, 100%. So this is actually the exact same as saying for int I equals 0. I is less than board.length I++. And then inside that array, inside this loop, it's actually saying Boolean row is equal to board at index I. So this is actually what the loop is. It's just a shorthand. So this is a short version of this. The reason we like this one is in this one, we have no int I, so we don't have to use ij. We don't have to say board I j, and we know I and j can be annoying because I and j look kind of similar, and it can be a bit confusing when we're writing. So this up here is the exact same as this. It's just a little bit shorthand, and we don't have to have both I and j in our loop. So now we can say we can check if this row has everything equal. I'm going to do it using a little boolean as a flag. So we'll have this boolean as a flag. This is a lowercase boolean, so it can only be true or false. It can't be null. And we'll say row all equal, and I'm going to assume that it's true. Now the technique here is we're going to say assume the rule, or assume the thing is true and prove it wrong. Wrong if it's not.
Okay, thank you.
That's going to be our algorithm here. And we're going to say if. So first we're going to check if the first thing is null, because if the first thing is null, there's no way that this one can be the winner, right? Because if any of the slots are null, and keep in mind we only care about the horizontal. So if this one is null, we can say this run is bad, so we'll continue. That means we'll go through the loop again, and we'll skip whatever comes next. Else we will say now that we know the first one is not null, we can iterate through this row and we can see if they're all equal, right? So we can say for int I equals 1, because we don't want to start at 0. I'll explain why we don't start at 0 in a second. Int I equals 1, I is less than row.length I++. That should be an open bracket. We're going to say if row at I minus 1. Remember, we can actually play with I because it's an int. You can do whatever you want with I. So I'm going to say at I minus 1, if it's equals to row I, or I mean if it's not equals, because we want to make sure that the things in it are all equal. So we're going to iterate through and we're going to check, do all of them equal everything else? And if they're not equal, we'll say row all equal is false. So we'll prove ourselves wrong. And then based on the value of row all equals, we can do something, right? So we can say after this runs, if row all equals, so if everything in the row was indeed equal by the end, we'll return whatever type was in the row. So return row at 0. Now, this code might be a little bit confusing to you guys because it might seem a little bit arcane. But here what we're doing, essentially, is that we are looping through. We're saying if the row at 0 is null, so if the first thing is empty, if the first thing is empty, we can't win. So we skip it all, right? We skip this row. And now the first thing is not empty. Now we check the rest. Thing isn't empty. Now we check that the rest is the same as the first, right? Now there's multiple ways to do this. This is just one way we can do it, so I can show you guys what it looks like to play with the index. So we started int I equals 1, and we then do I minus 1 inside. Now can anybody in the session explain to me why we want to start I at 1 here and not at 0?
Because we don't want an index error.
Yeah, that's correct, yeah.
Yeah.
We don't want an index error, so when you have a for loop where you do some math on the int I, so for example, if you do I minus 1 or I plus 1, you have to be careful about your for loop syntax. So for example, if I starts at 0, but inside your loop you have I plus 1, you have to do it until length minus 1. Hopefully that's understandable. I mean, it can be obvious in theory, but in practice, this can actually cause a lot of errors. And later on when we run the tests, I can show you guys that if we take out some of these conditions, we can actually run into a lot of exceptions. And now, can anybody tell me or have a guess at why we're using dot equals rather than just putting 2 equals signs there? Like, why do we have dot equals?
Is it because we're comparing arrays?
It's not because we're comparing arrays, but Jacques here in the chat actually has it. It's Boolean with a capital B. Now, what Boolean with a capital B means is that it's actually a reference to a Boolean. It's a pointer to a Boolean. If you know C++, you'll have heard of pointers. If you don't know C++ and you're coming from Python, then that's okay as well. What a reference type or a pointer is, it's actually not just a 0 or a 1 like a Boolean. It's a reference to a place in your computer's memory. So somewhere in your RAM, it says, let's say, like somewhere in the second stick of RAM in your computer on, like, you know, the 4th chip in, like, whatever part of the chip, there exists a 0 or a 1, and that is what we're looking at. But if that part of the memory has nothing, then that's also a valid value. It can have a 0, a 1, or nothing, right? That's a capital B Boolean. But since what we're looking at is actually a place in the memory, if we compare with an equals equals operator, that's a very simple operator. The equals equals operator compares directly whatever you throw at it. So if you throw at it a memory address, it's going to compare the memory addresses, right? So you can have 2 places in memory, where let's say both of those places in memory have a 1, and you have that Boolean. And if you do the equals equals operator, well, the equals equal operator doesn't know that you're trying to compare memory addresses. It just thinks you're comparing these 2 different things. And one says, let's say, this is the 4th stick of RAM in whatever chip, and the other one says, oh, this is the 2nd stick of RAM with whatever chip, and it says, well, those things aren't equal, so it's not equals. But both of them are a 1, if that makes sense to everybody. So dot equals gets around that. Dot equals actually goes into this reference type, and it sees, okay, well, this place in memory has a 1, this place in memory has a 1, therefore they are equals. That is the difference between equals equals and dot equals. Aslan says, is dot equal used for all reference types? Yes, it is. That is what we want to do. However, you can use the equals equals operator. It will just compare the references. So if you want to compare if 2 objects are actually 2 different things in memory, then you can use the equals equals operator. If you want to see if they are the same in all their properties but might be 2 different places in memory, then you can use dot equals. It's quite a technical thing, but in general, you want to use dot equals. You generally don't want to use equals equals for objects and for reference types. And again, for all you guys who are new to it, reference types are anything with a capital letter usually. Or by convention, all reference types have a capital letter at the start, and all non-reference types have a lowercase letter. So we want to use dot equals. All right, so that's this one. Has anybody had a chance or made an attempt at the vertical version? I'm gonna guess that nobody's finished it yet. If you have, that means that I can send it to the chat and I can put it there. And for now, I can do the diagonal one, and you guys are invited and encouraged to do the vertical one. And one last thing, if nobody wins, we'll return null. So return null. That's for that previous method. Quick question from Jacques. Here, the array contains big B booleans, meaning true corresponds to x, false to 0, or vice versa. It's easier than having an array of a string of 0, 1, xo, for instance. Oh yeah, so the reason that I do a capital B boolean is because, well, like in tic-tac-toe, we have 3 possible values. In tic-tac-toe, 3 values exist, x, o, or nothing. In boolean, 3 values exist, true, false, or null. You can see how it's kind of similar. So we use our boolean to save the most memory and be very efficient, and also mostly to teach you guys about reference types. Very efficient. We want to save the most memory, and we want to be efficient. So we use a type with 3 values. Like, does it really matter? Do we really care about the couple bytes of RAM that it would take to store like an int? Not really, but we do care that it's teaching you guys about reference types, and the capital B boolean is technically the least information you could probably use for this, right? Because it's just got 3 possible values. And if we use a lowercase boolean, well, it can only be true or false, so we can't have an empty spot on our board. That's why we use the capital B boolean. We use our capital B boolean. That's important. All right. So assuming nobody has the vertical winner, I'm going to go into the diagonal one right now, because it's actually the shortest and easiest one. But first, I'll ask you guys for ideas. Does anybody have an idea how we can go through the diagonal of our 2D array to check if all of the things in a row are equal? Tea cough down. Dang, my tea gave me COVID. All right, so if nobody has any ideas for it, maybe I can think about something, and maybe you guys can work with me on it to try to come to a solution. Damn, why did I drink that much tea? All right, addiction. So what we can do is we want to iterate through the indices 0, 0. Right, we want to iterate through the indices 0, 0. Then we want to go to the indices 1, 1. Then we want to go 2, 2. And then we want to go, dot, 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 until we get to length, right? Does everybody agree with that? When we're going through diagonals, we want to go through those numbers, right? For the first diagonal. And then for the second diagonal, we want to go through length, or I guess 0 length, 0 length, 1 length minus 1.
Sasha?
Yeah, what's up?
Can I ask a quick question?
Yeah, sure.
I'm just curious syntactically, the way you wrote that for loop again, I wrote it just for my notes, and I'm getting an error, and I've written it verbatim, but it keeps telling me on IntelliJ that like it's incorrect and it doesn't recognize row. But like I don't understand how I've written verbatim what you have, and it's underlining the word for, and then it's not treating row like it's ever been declared. So like, I don't understand how I'm not following you.
Okay, so we gotta be careful about where things are declared and where things are read. So this side, the second side, the one after the colon, this side is what's being read. Here I'm reading the variable board from the input of the method. You have to, if you're copying mine verbatim, you also have to take a Boolean array, double array, a board as an input to your method. If you don't have a double array of Boolean capital B called board coming into your method, you can't do that part of the for loop. Next thing we got to be careful about is the data type. We want to make sure that this data type is actually what gets iterated from this array. We can see here if I hover over it, it's a Boolean with a double array. So when you iterate through a double array, you get singles arrays of the same type. So here I'm getting single arrays of type Boolean. And then inside my for loop, making sure all my brackets are correct and everything, I can declare one called row. So row gets created here. Row does not exist up here. Up here, I can't do anything with row. It'll go red, it doesn't work. It only works inside the for loop. If I try to access row outside of the for loop afterwards as well, there's no such thing as row. Row only exists inside of the curly brackets after that for loop. Because we established the variable inside these circle brackets, therefore it only exists inside the curly brackets, right? Whatever is in here applies to what's in here. Otherwise, it will not apply at all. Assuming all of that, then the syntax should be the same, and I will send you the exact code I have so that you can just copy paste that in and see. If you still have an issue after you copy paste that, then there must be some really strange, mysterious problem going on.
Okay.
Alright, cool. So in tic-tac-toe now, I've got another method for a diagonal winner. Here are the numbers I want to see in my for loop. Can anybody guess how we could potentially do this with a for loop that's nice and clean? What can we do here? All right. Well, I'll get into a couple things. So we'll want a regular indexed for loop, right? Because we care about the index, so we can do for int I equals 0. I is less than board.length I plus plus. All right, we just want to go through the board, and here we get our int I. Now, what do we notice? We notice that this can just be I. We can just use I for both indices in the top one. Do we need 2 for loops for each diagonal? Last time I did 2 for loops. This time I'm thinking maybe we can see a pattern, right? So here we can just do I comma I. Does that make sense to everybody? We just want the same number in both. I starts at 0, it goes to length. So I comma I would work for that first part. Now for the second one, we probably want I comma length minus I. Do you guys see that? How, I guess length minus 1 minus I. Because the longest one we can do is length minus 1. I should be more clear about that, right? So length minus 1. Length minus 1. So I length minus 1 minus I. Right? So that could make sense, right? We can use these as the index like that. So for the first diagonal, we can write a bit of code. We can just check if everything is equal. We can say boolean boolean first. Or why don't I do it here? We can even yeah, we can do it like this. So boolean first is equal to board at 0, 0. Boolean second is equal to board at 0 and board dot length minus 1. So now we're just getting the first things in our first diagonal and our first thing in our second diagonal. Now we can say if first is not null, you know, check. Let's just create a lowercase boolean that's called check first. You know, boolean check first is equal to true. Boolean check second is equal to true. Now we don't want to check it if it's null because we'll get a null pointer exception. So we'll say if the first is null, we'll say check first equals false. And if the second is null, if second equals null, we'll say check second is null or equals false, right? And now we can use our loop through. Now we can say if check first, and then we can say if check second. So in here, in these codes, we want to do our checks for the first one and the second one. So now if we're checking the first one, well, we probably want to compare all of our booleans inside to the one that we want to win, right? Because if they're all the same, they'll all be the same as the one in the first index. So we can say if, so the first one is easy, right? It's just going to be if board at I does not equal, or I guess if the first one dot equals board at II. And can anybody tell me why I want to put the first, like, why would I put first dot equals instead of board II dot equals? Does anybody have a guess why when I check the equality I want to do first dot equals rather than board II dot equals? Board II might be null. That's exactly true. So if board II is null, we'll get an exception if we try to dot equals it. So whatever can be null goes inside of the circle brackets of dot equals, and whatever cannot be null goes in before the dot equals. So not null before dot equals, maybe null after dot equals. Right? That's an important bit of syntax. That's really going to save you a lot of exceptions if you remember this. That's a golden rule right there. All right, so now if it's not equals, we can say, check first equals false. Right, we don't want to check the first one, or there's going to be no winner in the first, and maybe we'll say, yeah, we can say that. We can say check first is false if they're not equals. Now, similarly, we can do a for loop through the second one, and we can say if second dot equals board, now and now we want to do length -1 minus I. And this will iterate through our second diagonal. Think about it. Once we get to the last index, we will get to the length -1 and 0. It'll follow this loop syntax, right? So here we'll do it like this. We'll say, yeah, and here it's going to be like this. Now, I'm not sure if this will work. I mean, I wrote this method like this. I just came up with this solution right now. So let's hope this is going to work. Now, after our for loop, we'll say if check first, return first. If check second, return second. And then, if neither of them, return null. So here, after my checks, if it's neither, we'll return null. Does anybody have any questions about the code here? So this one is lots of playing with the int I. So we only do one for loop here. I see, Michael, you have your mic on. You're welcome to ask away if you have a question.
Sorry, I forgot to turn it off.
All right, perfect. So if you guys have any questions about this check diagonals, then you're welcome to ask still. And if you don't have any questions, then I can move on to vertical winner. And if anybody has the code implemented for vertical winner that they did on their own, they are encouraged to send it to the chat, and we can try to implement their solution.
Can you just explain again the difference between the uppercase and lowercase boolean?
Yeah, so the uppercase boolean, the one we use for our winner, can be null, true, or false. And then the lowercase boolean, which we use for our whether somebody won or not, can only be true or false. So this one has 2 possible values. Or this one, like check first, that has 2 possible values. And this one with the capital, that has 1 possible value. Or that has 3 possible values, which is true, false, or null. Someone asks if it's recorded. Okay. Yes, it's recorded. It doesn't record through Zoom. It records through my streaming software, so that's why you're not seeing the recording thing on Zoom. All right, so...
excuse me?
Yeah, go ahead.
Where did you define the board?
The board will be defined later. It will define it when we actually write our game. Right now, we just take it as an input to our methods. So we're just writing a method which takes a board as its input. In our test, we define our board here. So in the test, we create this variable board, and we test it, and we create lots of different boards to test all our different ones. And you don't have to worry about how the test is written. Can we use Boolean column? Well, do you have an idea of how we can implement a capital B Boolean column? Because, again, we have to kind of access our array weirdly, because it's a 2D array, and it doesn't work exactly like a matrix, right? It works like a list of lists. So we can't really use this without the index for loop for it. Because we have to play with the indices. I'd say I haven't come up with a solution where we don't play with the indices. All right, so going through the implementation, we can just do a regular for loop to start. Maybe we can use I and J, but maybe there's a way we can avoid the J. Let's take a look at it. I'll write the for loop and we'll look. So for int I equals 0, I is less than board at index 0 dot length I++. And we'll say, you know, whether it's all equal. Should we do our check? Yeah, we can do that check. We can say Boolean column all equal. Boolean column all equal. And we're going to assume it's true. Now, what do we know about the first thing in the column? Well, we're going to be checking, we have our list of lists. We want to be checking the first index of each list first to see what they are. We're not iterating through the lists in a normal way. We will use ing, but we'll use them weirdly. We're not going to use like an enhanced for loop right away. We're gonna put a for loop inside of our for loop with ing, but we're not always going to use it. Let me explain. So we'll look at the first thing in our column. So column first is equal to board at 0 and I. Now it's really weird that we're putting a hard-coded value for our first array and a soft-coded one for the second, but that's because we want to only look at the things in the top row of our array, and we want to see if that one is going to be null, true, or false. So now we're going to say if column first is not null, else. So if the column first is null, we'll just continue, right? We don't want to do anything. If the column first isn't null, we can say for in j equals 1, j is less than board.length, j++, now we only do this for loop partially, we can compare things to our column first. So we can say if board at ji I dot equals, I guess not dot equals, if not board at board.ji equals our first in the column. And again, this is breaking our rule, so we want to say our column first dot equals board.ji because we want to put the thing that could be null in our in this part of the dot equals. So ji. If our column first is not equals to our board.ji, we can say column all equal is false. Equals false. Right? And then we can break. So this is checking if everything in our column is all equal to each other. If they are still all equal to each other, by the end of this loop in this column, we can say if column all equals, return column first, because we know that the first one is equal to all the others, therefore they won. And then this will be run for every single column. Does this kind of make sense to you guys? We're using the indices in what may appear to be like the wrong place or an unexpected place. We're using the index in the second part of our, we're using the index I in the second part of our double array, and we're using sometimes the index j in the first part of our array. It's an unconventional, weird for loop because we're using j to access the first element and I to access the second one. So we're not exactly using an ij for loop, but we are doing a for loop with two indices, if that makes sense to everybody. If anybody has any questions about this method, you're welcome to ask.
What if those the first element of the columns are all nulls?
Well, then we will just always do continue, and we'll just return null for our winner, right?
Okay.
Nobody will win, so we'll say if column first is not null, we do all this. If column first is null, then we will just skip everything, right?
Yeah, thank you.
Cool. So let's now test our game rules. Let's see if they work, and let's also see what's wrong with vertical winner. Tic-tac test, vertical winner, everything looks totally fine here. So now if we run our tests, which we'll just do by clicking the play button next to tic-tac test, let's see if anything fails. It might fail for real, because like I didn't ever test these methods. I wrote these differently this time. So no, it looks like nothing failed. If something fails, we'll have a print line. Like if I screw up one of these methods, then we should have an error. Let's say, let's just say that one of these is true from the start. Let's put a really big mistake in here, and let's run tic-tac test. Now we get a null pointer exception. See, we get a mistake if one of these things is wrong. So that's the point of our tester, and it'll print line depending on what your mistake is. And you can actually see if I get this null pointer exception, the IntelliJ readout is always very helpful with them because it tells you what's going on. So here it's saying cannot compare it because the first one is null. We can't do the dot equals because whatever is coming first is null, right? Should make sense to you guys, right? So now our tests pass, and we're wondering how do we make this into a tic-tac-toe game? This is where the second half of our tutorial and the more challenging part of our tutorial conceptually comes in. We're going to write an object to represent our game. And right now we have our tests, we have our rules, but we want to actually create a game. So can anybody tell me, what does every game of tic-tac-toe have? Every time somebody in the world plays tic-tac-toe, what do they have that's unique to their game of tic-tac-toe? Maybe I should rephrase the question. Every time there is a game of tic-tac-toe that is started, something is created, right? So what do you create every time you start a new game of tic-tac-toe?
The board?
Yeah, that's right. So, and the board is not the same for every game, right? So if let's say two of you guys are playing tic-tac-toe at the same time, there's two separate games going on at the same time. You guys are not on the same board, right? You guys have two separate boards.
Sorry, what do you mean two different separate boards?
Well, you know that if
Should we
two-
just play
if-
on the same board?
if multiple people have a unique board, right? If they're playing unique games, they will want separate boards. Let's say that in our class we have more people than one tic-tac-toe game can accommodate. So for everybody to be playing tic-tac-toe, they all have to have boards. And if everybody has the same board, you're going to see moves going on, and there's not going to be enough for everyone, right? So every board for every game has to be unique. Every time you start a game, every time if you play a video game, you start game, like you create like an instance of the game. When you start it, you start fresh. It's not the same as the other times you've played the game. It's not the same as other people playing the game, right? So for that reason, we actually want to have what's called an object. An object is something that has multiple instances of itself. It's like a blueprint. It's like a template for other things. So our object, again, acting like a template, you can create an instance of it, which is like creating a game of tic-tac-toe, starting the game. And when you create the game, it will have certain properties, and it'll have certain unique aspects to it that every game has differently. But there's also things that can be the same between every game. And that's what static means. Static means that these don't vary between games. These are the same no matter which game you're playing, right? Static means that when you do this, these rules, these things stay the same no matter when you start the game, no matter how you start the game, no matter when you start the game, no matter what. These are always the same for every single game, right? So that's why we can say the rule of tic-tac-toe. We're saying the tic-tac-toe horizontal winner rule is being tested. That's because it's static, and this rule is the same no matter when you play tic-tac-toe. That's why we don't have to start a game to test it. We don't have to create our game to test our rule, because our rule is the same no matter which game you play. Similarly, if we have something that's also the same, let's say static string name is going to be equal to super Tic-Tac Bros Ultimate 2 Electric Boogaloo. Right, that can be the same for every version of our game, because no matter when you start this game, no matter when you click play on it, it's going to have the same name. But the board will not be static, so we'll have a Boolean board which is not static, and we can make that private, and we won't talk about why it's private right now. But we will in later tutorials, what private means and all about that. But for now, just know private means that if you're outside of this tic-tac-toe.java file, you can't touch it. So we've got our private Boolean board and our public and our static string name. But now if I try to go into tic-tac-test and I try to say, let's for example say tic-tac-toe.board, tic-tac-toe.board, board, it doesn't show up. See in my suggestions, we can do .name. And notice how I declared .name in the same place I declared .board. .name will not let me call it because it's static. .board will not let me call it because it's static. So can somebody give me an idea of how I would be able to get access to board even though it's static?
Call the class name?
Well, I can type the class name. I can say tic-tac-toe .board. It's not going to work. And I can say tic-tac-toe.getBoard, and you know what? I can even write a getter method. Let's say I want to be able to get the board. So I can, in IntelliJ, you can right-click generate getter, and we just get a getter, right? And we'll do it for board. Okay, now IntelliJ has written our getBoard method, and it's public. But now, can we do tic-tac-toe.getBoard? We can't. That's wrong. Now, if it was static, yes, we could. So if I write a getter for the name, if I make the name private, and I then create a getter for it. So if I right-click generate getter, that's true. We can access the name. So I can do get name, but I can't do get board. Can anybody give me another guess?
If it's non-static, then you'd have to create an object, right?
That's correct. So we have to create an object. So how do we go about this complicated process of creating an object? Well, we do something called the new keyword. So here in my main method, where's my main method down here? I can say tic-tac-toe game is equal to new tic-tac-toe. And now I can say game.getBoard. See, so I have to be able to have this game object, which is an instance of tic-tac-toe. And then I can get the board. Why? Because I can have more than one game going. I can say tic-tac-toe game 2 is equal to new tic-tac-toe. Tic-tac-toe, and they might have different boards. So I can say game2.getBoard, and let's say game 2 might have like a 5x5 board where the game is finished, and game 1 might have a board that's 3x3 and still going on, right? You can see how multiple games can have multiple boards, right? You can have multiple games going in once, and each board will be unique between them, right? That's why we have to say game.board. The whole idea of tic-tac-toe, all tic-tac-toe games don't have a common board. The board varies by game. The rules are the same for every game, but the board is different every time. That's why we need to have a non-static board, which we cannot access until we create a game, and a static rule, because the rules don't change, so we don't need them to vary by game. Does that make sense to everyone? Cool. If you have any questions, we'll have time at the end. I'm going to speed up a little bit now because we are running out of time and I want to be able to write playing the game. But we're not going to speed up too much and there'll be time for questions at the end. So now I'm wondering, how could I make it so that when I create the game using the new keyword, that the board is initialized? Because right now, our board is nothing. There is no board. So how do I make it so that when I create my game, a board is also created? Does anybody have any idea?
Constructor?
Yeah,
Just put it in the
constructor.
constructor?
That's right. Because when you call the new keyword is actually special. It calls a method. It might not look like a method call, but this is calling a method. And the method is calling is the tic-tac-toe method. So what is the tic-tac-toe method? We have no such method. Well, that's the constructor. If I type public tic-tac-toe, this is a method which has no return type. Public tic-tac-toe, like that. That is our constructor. It has, again, no return type, and it can have inputs. So does anybody have an idea what kind of input our game might need?
The size?
Yeah, that's correct.
The size of the board?
Yes, when you create a game, you need to know how big your board is going to be. Because your board will not change while you play. The board size is something that depends in the constructor. So we can say int size, right? And then inside the constructor, we can say board is a new board. Board is lowercase. Or it's not a new board, right? Because it's not an object. It's just an array. So we can just say board is equal to new boolean, right? Because board is not an object. Board is just a variable. It's just a new boolean, and its size will just be size. It'll be of size, well, size on both axes. Does that make sense to everybody, right? Because the board is not a type of object. Board is just a variable, and we set it in our constructor, and then we just use it with the new keyword, and we use new boolean because boolean is an object, just like a tic-tac-toe. And in fact, everything in Java is an object, just like that. And the same rules apply. Now let's say make the size of this one 3, and the size of this one 5. And now if I run this with the debugger, I can actually see that the board of our game 1 is of size 3, and there's 2 separate games, right? So we'll go forward, skip over a couple lines, and now we have game 1, and game has a board which is 3x3, and game 2 has a board which is 5x5. You see how it's useful to have 2 separate games and how it's useful to make it not static? Alright, so now we have our constructor. Now we can write a method for playing the game. Remember, we have some game rules, so we can say, let's say public or void, public void play. And we will...
Sorry, when you declare initialize or whatever the board, don't you have to have, write boolean on the other tab? In the constructor, within the constructor. Don't you have to say, boolean? board?
No,
Like on
because
the
I'm actually,
left?
I wrote Boolean over here. So when it's a field, which means the field, you
Oh,
know how
right,
every
okay,
tic-tac-toe
right.
game has this board? That means that it's a property of the class, and I can access it by saying board, or I can say this dot board. If I have a local variable called board, if I say, like, for example, string board is equal to whatever, hello, right? Then I have to say this dot board, and that's how I access the field. Or if I have nothing else called
Okay,
board,
yeah,
I
okay.
can just say board. All right, so now we have a play
Okay,
method. Now the
thanks.
play method is going to be how somebody makes a move. We'll say int x, int y, these are our coordinates, and who's playing. So Boolean x or o. Now, a couple of checks that I'm just going to go through really fast that are pretty self-explanatory. If you want more detail on them, you can watch the recording. I just got to go fast so that we can finish in time. We'll say if y is inside of the board, we can say y is board.length -1, -1, or x is outside of the board, x is greater than board.length -1, or if we want to be very formal, we can say board 0.length, so we can check the correct axes, dot length -1. And this is just so we can't screw up. We can say throw new illegal argument exception. You're out of bounds, son. Now, if we want to be, if the player is not, so we want to make sure that the same player can't play twice in a row. So what we can do is we can have a tracker for that. We can say, private Boolean last player is equal to null. And now every time you play, you can say that the last player is changed, and we can check if the last player is the same as the current player, right? So we can say if Zoro x Oro dot equals last player print line. We want to throw new illegal argument exception. Yeah, can't play twice, fool. Right, and if one last check we want to do, and then after we do this check, we can say that our last player is equal to Zoro. And now we can say if board at yx, and that's just because I mixed these up a little bit, yx is not null. We can say throw new illegal argument exception, cannot place where there is a thing. Oops. Right. Now, nice. Now that we've done all our checks, we can just set that part of our board to be our, our thing. So we can say board at yx is equal to Zoro. And now we can check our winner. So we can say if vertical winner, or we can say Boolean winner, let's say Boolean winner. And now if vertical winner of board is not null, and we don't have to put the curly brackets if we just have a one-line thing. We'll say winner is equal to vertical winner on board. And then we can do the same for all our other types of winners. So if vertical winner on board is not null, horizontal winner, and if diagonal winner. So if horizontal winner, and if diagonal winner. Now we can say if winner is not null. So if somebody won, we can say if winner, system.out.println, or we'll even return. We'll say return, because we'll make it a string. Let's just say that our thing will return a string if somebody wins. Return x wins, else return O wins. And now that we have a winner, Boolean winner, come on. What's wrong with this? Oh yeah, we need to initialize, so we'll say null. If Boolean winner is not null, we'll display that. Now, after we play, we might want to, clear the board if somebody won. So then we can say board is equal to new Boolean of size, board.length and board.length. Oh, I forgot to check. That's very good call there. They shouldn't all three be vertical winner. They should be the correct kind of winner. I just forgot to paste that in there. All right. So now our board is going to be created there, and also we want to display the board right before the person won. So now we can call the display method, which we haven't written yet. Does that all make sense? Yeah, sure. So now let's create the method, and we'll return if nobody won. And now our display method, let's write it. Create method display in tic-tac-toe. And that method will go through our board and print it all out. So this one we can be very quick. We already iterated through our array a lot, but this will be very similar to one of them. So we can say for Boolean array called row in our, and we might go a little bit over time today as well, but I will get to the automated playing now. Instead of doing a 2-player game, we'll do a 1-player game today compared to last time. So if our item, oh, now I have to do a for item, sorry, for Boolean item, because we don't care about the index here. If for Boolean item in row, we will say if item is null, we will system dot out dot print. Now an empty space, how do we want to represent our empty space? We can say it's just going to be a dash. Now if we want to have an x, we can do system dot out dot print x. And if we have, and yeah, if you guys stay tuned for when we're implementing the game, we will also have a an explanation of random. System.println x and o, these shouldn't go here, they should go into other if statements. So yeah, if you guys stick around to overtime, I'll show you guys how to use the random class. So that will be quite useful. System.out.print x and else system.out.println, I said system, print oh. Now we've got our printers, and we can say that at the end of each row we will system.out.println, and we'll print line nothing. It'll just create a new line. So now this will print our board. Now we have a couple of useful methods. We've got display and we've got play. Now, are there any other methods we need? I don't think so. So we've got play, we've got display, and now we can create our game. So I can create, what's print and print line? Print just like throws something into the terminal, and print line prints a new line. So like it creates another line. We'll see it there. So now I should actually put these in here. All right, now we've got our various methods, and we create our main method now. And our main method can actually play the game for us. And in our main method, we can put our main in this class, or we can put our main in another class. I'm going to put it in another class just to follow a certain rule called model view controller, which we'll see. You'll see later on in your career in CS, the model view controller pattern, especially in ECSE 223 if you're in ECSE. But just for now, you know that I want to separate my game from my interface, so I'm going to call it tic-tac app. And in here, I'll have my main method. Now, I'm only separating these because of convention. So we'll say, public static void main string args. And in here, I can do all my stuff. So I can say system.out.println welcome to, and now what's the name of my game? I can do plus tic-tac-toe.name or get name, because that's static. Now I can say scanner s to get user input. Scanner s is equal to new scanner on system.in. Oh, and I forgot to do my overlays all day, haven't I? Always forget those. Oops. Anyways, new scanner, and then we can do system dot. I'm just going to speed run this out.println. How big is your board? And now we can say int board size is equal to s.nextInt. And then we'll say tic-tac-toe game is equal to new tic-tac-toe of that size. All the code is up on my courses, yes. Or will be up on my courses, already is as well. But now the important parts is what I'm going to get to right now. So the game is going to be a new tic-tac-toe. We're going to say Boolean player, or it can actually be a lowercase boolean. Boolean player is equal to false. Right? And now we're going to say while true, string player is equal to O. That's going to be the name of the player. Is equal to O. Yeah, should I? No, not player. String name is equal to O. Now, if the player is player, name is equal to X. And now, here's where the robot comes in, right? We're going to have an AI that we can play against. So here we can say, we'll create a random. We'll up here, this is part of this. We'll say random rand is equal to new random, and this is what's called the random class. It can generate random numbers for us, just like the game. We can call the constructor, and we can put a number here, and that's the seed. If you ever played Minecraft, you know how the seed affects how the world generates. This is the same stuff. In fact, Minecraft may use this very same random object in Java because it's written in Java. So you put the seed into your random object, and then that will help it to generate random numbers based on that seed. If you have the same seed, the random numbers will generate the exact same way every time. We don't want to give it a seed now, or we want to give it an unpredictable seed. So what I'm going to do is I'm going to say system.nanotime, and this is going to use the nanosecond of the current time as the seed for my random. So it's going to be truly very random as to how the robot will make plays. Now we're going to say if it's an X, it's going to be let's say U, and if it's not an X, it's going to be a robot. So let's say the O is the robot. We can say, and we'll make the player have the first move. Now we're going to say, when the robot plays, we're going to do, let's say int X is equal to rand.nextInt, and it's going to be on board size. So the maximum number it can generate is the size of the board. Int Y is equal to rand.nextInt, also on board size. So it's going to generate a random number that's as big as board size at maximum, and that's going to be where the robot's going to make its play. And now it's going to try to play, and it's going to try to go. But one problem is, what if the robot plays on an invalid spot? Remember how we threw those illegal argument exceptions? Can anybody have a guess as to how we can make it so that the robot won't make mistakes, or at least if the robot makes a mistake, it won't be a bad one? So what do we do if the robot plays onto a spot where it shouldn't play, where there's already an X or an O, or off the board? What can we do to make sure that the robot doesn't screw up? We can put its move in a try. That's correct. So we basically want the robot to keep trying until it succeeds. So we're going to say Boolean robot has played is equal to false. We're going to say now try, or we're going to say while robot has not played. We will say in X, in Y, we're going to say try game.play on X, comma Y, comma player. And then if that succeeds, we'll go to the next line and we'll say robot has played equals true. And if it fails, we'll catch illegal argument exception E. And just for fun, let's see all the mistakes the robot makes. We can turn this off later. Print line, and then we can say E dot get message. So now we can see all of the ways the robot will screw up, just for fun. We don't have to do this. If you don't put the print line, the robot will just play properly, and if not, we'll say, robot is dumb, right? And whatever the robot did to screw up. And now every time that a play is made, we will also game.display. But I didn't make display public, so I can't play it. Now, again, I see display is a method that exists, but I can't call it from out here because I forgot to make display public. How do I fix that? Well, I changed from private void display to public, and now the game will display. Now I did the robot's turn. Now I can do what happens in our turn. So if player name is X, system.out.println, or we'll do we'll do a game.display first. Println what X chord int X is equal to s.nextInt. Similarly, see, we do like the same looking method. It looks quite similar. It's just we get from random for the robot, and we get from you to get this. And then set y chord int y is equal to s.nextInt. And then we'll say game.play x comma y comma player, and then we will then we'll just loop through, and we'll say now at the end of each turn we'll say player equals exclamation mark player, and that's so that we can swap who the player is every time we play. Say player is equal to exclamation mark player, and then in here we will also say if the robot does successfully play, the player will be changed. So player is true. If the player is true, we'll invert the player. And if the player is false, we will change the player. In fact, we can do this after the while loop. Now the player should successfully be changing every time the game is played. Alright, now if we run this main method, hopefully it'll all work. How big is your board? Let's just do a 3x3 game. What x coordinate? Let's do 0, 0. Now the robot played. Now I can just play against the robot. So I can do, the robot played at 0, 1. I'm going to play at 0, 2. The robot played, I think the robot might actually be better at this than me, even though it's random. I'll do 2, 1, so he doesn't win. And now the robot is being very dumb. But no, actually it's not the robot being very dumb, it's me being very dumb. Because the player inversion condition didn't work properly. So now we can try something else here. Players, exclamation mark player. But yeah, generally we can see here, the tic-tac-toe game appears to work if I do a 5-sized board, and my x-coordinate will be 0, 0. What x-coordinate? 0, 1. Let's see if the robot will make me lose. 0, 2. And now it looks like I always have this mistake where the player change doesn't work, even though it looks like it's the same as ever. Anyways, I have all the solution code up on GitHub, and if you guys have any questions, you're welcome to ask. Now is the time. And
so is big Boolean, the only difference between little Boolean and big Boolean is that big Boolean has 3 possible variables that I can hold?
The only difference that we're using between big bool and little bool is that it can hold 3 values, but in real life, a big Boolean also has helper methods. So big Boolean will also be able to have a method called like parse Boolean, which can take something else as an input and turn it into a Boolean. So it can take a string, let's say true or false, and convert that into a Boolean. Boolean with the big letter is actually a class, similar to our tic-tac-toe one, and its only field is a Boolean. And it has methods that help you with Booleans. It's kind of like a built-in helper class with Java. So it has other methods, but we might not use them. And we'll learn about that later. Don't worry, it's a big subject, so next tutorial we'll be covering it more. Next tutorial is all about objects.
Thanks.
Sure. Any further questions? Alright, I'll wait a second for you guys if you have any questions to formulate them, and just give you a bit of time. And if there aren't any, I'll wait like a couple minutes, play a few rounds of tic-tac-toe, and yeah, I'll take any questions you like, any topic, or what have you, chat or voice. Alright, let's see if I can get through a whole game of tic-tac-toe. How big is my board? I'll make it 3 by 3. So 3, what, how big is your board? 3. What x coordinate? I'll do 1, 1. I'm actually going to try to beat the robot this time. So the robot played in the center here, or the robot played below me. So I can do 0, 0. And I'll try to do now 1, 1, or 2, 2, 2. Oh, and I won. So I forgot to print line the gameplay. So system.printline. Game.play. A little mistake there. I forgot to display if there's a winner. So now I should be able to win the game and have it displayed. I'm going to assume there are no further questions. I'm just going to run this successful game of tic-tac-toe, and if nobody asks by that time, that will be the end of the session. Thank you all for coming. Next session is going to be about object-oriented programming. Right, and now 2, 2. Okay, perfect. So the X wins, and it appears to all work. So we've been able to successfully beat the robot at the game. And there we go. So that's tic-tac-toe, that's object-oriented programming, and that's arrays. Thank you guys so much for coming. If there's any further questions, Piazza, office hours all around. The next session is on Tuesday at 2 p.m. I encourage you to come live and enjoy. Spread the word, tell your friends, it's going to be a really fun time. You'll learn all about objects. Assignment 1, quiz 1, we'll grill you on that stuff, so better be prepared. All right, enjoy.
Just a quick question.
Yeah.
Yeah, for the live session, the live session is unique each time or repetitive for each week?
For the tutorial or for the live sessions?
Tutorial.
Yeah, so every single week is a new piece of content, and then on Tuesday, I'll try to teach it one way, and maybe I'll make some mistakes on Tuesday, or I will cover some topics improperly, like, you know, or I'll do it differently on Tuesdays. And then on Friday, I will do kind of a condensed version, like a more refined version, and I'll do things differently. The example is on Tuesday this week, I did the same game, but instead of doing the arrays first, I did the objects first. Like I did the object part first. I made this constructor first. Then afterwards, I did the static methods. And when I made the game, I made a 2-player version instead of the robot version. So it's a little bit different. It's a different order. And if one of the sessions doesn't make sense to you, then you can come to the other one. So if you watched, for example, Tuesday, and it did not make sense for you that the objects were introduced first and the arrays were introduced second, then you can come to Friday, and it's a bit of a different explanation so that the people who didn't understand on the first day can understand. So some people from Tuesday I saw came back today to try to understand better some of the stuff that they might have missed on Tuesday. And then, for example, also the way I did the loops is different. So on Tuesday, I wrote 2 for loops, just 2 separate for loops for each diagonal. Here I wrote 1 for loop that covers both. So it's a bit different, and it can show you different techniques, but but you're only encouraged or expected to come to one of the two. Like if you're expected and encouraged to just come to 1 session a week.
Okay, so if I understood you correctly, what you meant is that the content is the same, but there might be different in the way that you show the content, right?
That's absolutely correct. Yes. And if it is
it's
a very complicated time, and let's say, for example, we have an assignment due the next week, I might do 2 different ones in the same week. I'll make an announcement if that's the case. So it'll be very obvious. And if that's the case, that's because there is so much content right now that people need it. Or I might do special ones, like I might do a special one day. For example, like assignment special. If it's the day the assignment is due, we could do like a big special, which is very close to the assignment and is just a public question segment where you can ask how to do methods that are close to the assignment. It's kind of a game of how close can you get without asking about the assignment, and it can be really helpful. So that kind of session can happen, but those will be specials, and those will be announced when they happen.
Okay, thank you very much.
For sure. Enjoy your day. If any further questions, happy to answer. Otherwise, see you guys later. All right, farewell. Enjoy your day.